Hello children, this is your physics teacher Sharma and I welcome you all back to my class again. In today's class, I want to give you a briefing about atom and its structure. Earlier, atom was only considered to be an indivisible particle, that was according to John Dalton. Dalton proposed that atom is a tiny indivisible particle. Okay, and he stated that all atoms of the same type will be having same properties and atoms of different elements will be having different properties. Okay. Later, J.J. Thomson, after his discharge tube experiment, he came across or he confronted actually, he came to know that atom is actually having very tiny particles inside it, and those were later named by G.J. Stoney as electrons. Now, based on that, J.J. Thomson has put forth his theory, which is called plum pudding model of atom, wherein J.J. Thomson stated that atom is spherical and totally filled with positive charge, and negatively charged electrons are scattered all over them. Now, on the further development, when Rutherford was doing his experiment about the penetration power of alpha radiations through different membranes, different material, he identified that these alpha rays are not going in the same way. Their path is changing when it is traveling through a gold foil. Okay, he identified that the reflection or the deviation from the path is more in few places and the deviation from the path is less in some cases. So upon close observation, he came to know that the entire positive charge is concentrated at the center of the atom, which he called it as a nucleus, and that's the reason why these double ionized helium atoms, which are positively charged, otherwise alpha particles, they are deviating when they are trying to come close to the center of the atom. So based on that, he gave his model of atom, which is called Rutherford's planetary model of atom. Now, why did he call this as a planetary model? I'll tell you how. Rutherford stated that the atom is spherical in shape and the entire mass of the atom is concentrated at the center, which he called it as nucleus. He also said that the size of the nucleus is very small when compared to size of the atom, and entire positive charge is concentrated at the center. Now, what about negatively charged electrons? These negatively charged electrons are revolving around the nucleus in circular paths, just like planets revolve around the sun. And that is the reason why he called it as planetary model of atom. Later, it suffered its own drawbacks and it was taken over by Niels Bohr. Niels Bohr stated that definitely atoms are spherical in shape, electrons are revolving in orbits which are having fixed amount of energy, okay, and he called those orbits as stationary shells or stationary orbits. As long as the electron is revolving in the same shell, there is no loss or gain of energy. On the other hand, when an atom is jumping from inner shell to outer shell, it absorbs energy, and when the electron is jumping from outer shell to inner shell, it is giving away energy. This is what Niels Bohr proposed, and with the help of this model, he explained the spectrum or the energy that is given out by hydrogen atom so beautifully that he was given with a Nobel Prize for that. Okay, so now we actually have an idea about what atom is and what are the particles present in it. Atom is spherical in shape. It has its nucleus at the center. Nucleus is made up of two particles, protons and neutrons, and electrons are revolving around the nucleus. Now coming to charge. Okay, protons are positively charged particles, electrons are negatively charged particles, each having 1.6 into 10 to the power of minus 19 coulombs of charge. Now coming to neutrons. Neutrons don't carry any charge, they are neutral. Now coming to mass. Here we come across two terms. One is atomic mass, the other one is mass number. Please don't get confused between them. Okay. When we say atomic mass, the mass of the atom is because of protons and neutrons only. Because electron mass is negligible. If you take one proton and break it into 1837 pieces, 1837 pieces, and from that you pick one piece out. Okay, so that will be the mass of one electron. So which is very less. It is almost 2000th part of a proton. So mass that is contributed by electron to the mass of the atom is negligible. So mass of atom is completely because of protons and neutrons. These two have almost equal masses. Okay, now the number of protons into their mass, okay, plus the number of neutrons into mass of one neutron actually, mass of a proton into number of protons plus mass of neutron into number of neutrons. This is giving us the mass of the atom as a whole. Okay, and it is expressed in terms of AMU, atomic mass unit. Now what is mass number? Mass number is actually the number of particles which are contributing for the formation of or for the mass of the atom. Okay, for example, if I take hydrogen, mass of hydrogen is 1. Why? Because hydrogen has only one proton. Okay, so it is 1. If I consider helium, helium atomic number is 2. That means it has 2 protons. Okay, now its mass is 4. Why is it 4? Because this helium atom is having 2 protons and 2 neutrons in the nucleus. So there are 4 particles which are contributing for the mass of helium atom. So the mass number is 4. Okay, so this is how mass number is different from atomic weight, atomic mass. Okay, now coming to the third point, isotopes. This is one factor where I come across many students getting confused. Okay, now isotopes are those substances which belong to the same element, okay, atoms of the same element, but they are having different mass number. Now, how is that possible? It is. Let me tell you how. When we say it is the same element, that means same atomic number. That means they belong to the same element. Okay, number of protons is same. Okay. However, we already know that atomic number is nothing but number of protons. Now, the same element can have, that means 2 atoms of the same element can have 2 different number of neutrons. Okay, for example, if I say hydrogen, it has 1 proton, okay, and 1 electron. We know this. There will be some hydrogen atoms which will have a proton and also a neutron along with electron. Okay, we call it as deuterium. Similarly, there will be some hydrogens which has only 1 proton and 2 neutrons along with 1 electron. Okay, so what happened here? The mass number is 3. Okay, normally what we say hydrogen atomic number is 1, so mass number is 1. Whereas in this case, what is happening? The atomic number is 1, but the mass number is differing. Now these particles which are having same atomic number but a different mass number are called isotopes. Okay. Now coming to the calculation of number of neutrons. See, we already know that protons, neutrons and electrons are present in the atom, and mass of the atom is completely because of protons and neutrons. Now if you are given with, say, atomic number and mass number, can you identify the number of neutrons? There is a procedure for that. If I take lithium, lithium atomic number is 3 and mass number is 7. Okay, so how many protons do I have? Because the atomic number is 3, it has 3 protons. Okay, protons and neutrons taken together, how many do we have? 7. So if I want to find only the number of neutrons, what do? The total mass number minus the number of protons. Okay, so in this way we can find the number of neutrons. This is all for today's revision class. Until we meet again in the next class, have a nice time. Bye bye.